question 1, we are given here, the statement says that the arithmetic high school decided to compare results of 31 grade 12 learners in maths and physical sciences in 2019 of the preparatory exams. So the maths results were recorded and that of physics. So the physics results are represented using a box and whisker plot, and marks are recorded as percentages. So as you can see here, we're having the results of maths and physics. These are for maths and these are for physics. So now in 1.1, we are asked to calculate the mean mark of maths learners. So we're having these marks for maths, and to find the mean, we know that it's going to be the total marks divided by the number of learners, right? Learners. So the total, so we're going to add all the numbers, 7, so we're going to add 7 plus 11 plus 15, all the way up to 96, which is the last. So you add all the numbers that exist in this table, and you divide by the number of learners, which is 31, and your mean should be 51. So that is the mean for maths. Comment on the skewness of mathematics data. So for the mere fact that we're having a mean of 51, it tells us that most of the numbers are ranging within 51%, right? All the marks for these learners, they are ranging, at least most of them are having an average of 51. So this means now that our skewness is going to be positive. So it's going to be positive skewed, right? So it's going to be positive skewed. 1.3, determine which subject performed better in 2019 preparatory exams and give reason for your answer. So how do we know that whichever subject performed well, whether it's maths or physics? So how we can find out is the following: is we can find the 25%, which is the Q1, the lower quartile of maths, and you'll find that the lower quartile will give you 28%, right? The lower quartile for maths will give you 28%. How do you find the lower quartile? You say 25. Q1 is equals to 25%, divide by 100, multiply by 31 learners plus 1, right? And then what you'll find here is so you'll find 8. So this is number 8. So you're going to count your numbers. If these numbers in this table are written in ascending order, then you're going to count up until the 8th number. So it's 1, 2, 3, 4, 5, 6, 7, 8. So this is your Q1 for maths. So this is going to give you 28, right? So Q1 for maths is going to be 28%. And then Q1 for physics is this one, which is 40%. So you can see now that the lowest performing learners in physics got at least 40%, and the lowest performing learners for maths got 28%. So definitely physics learners performed well, or performed better than maths in this question here. So you can simply write Q1 for physics and then Q1 for maths, and conclude by saying this statement here. Now, 1.4 says that write down a possible mark for a learner who achieved the 10th lowest mark in physics. So this is what we're going to do. So let me erase everything here. So we should write down a possible mark for a learner who achieved the 10th lowest mark in physics. So, but we don't really have exact marks for physics, right? So let's use maths to really find this estimate. You know, the 10th learner who achieved so let's use maths to find this estimate of the 10th learner who achieved the lowest mark in physics, because in physics we don't have real numbers here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th lowest mark got 38% in maths, right? But remember, the difference between Q1, the Q1 of maths was 28%, and the Q1 of physics was 40%. So the difference between the two, the difference between these two is actually 12%. So if we're to at least add 12% in this 38, so it's going to be 38 plus 12%, it's going to give us 50. So we can assume that the lowest learner got 50%, or someone can just assume any number between just above 38 and 50. So I will just take the final answer to be 50%. And then, so we're done here. Now, 1.5 says that a learner scored the 4th highest in both subjects. The learner obtained the greatest possible difference between both subjects. Calculate the learner's mark in physics. So, the 4th highest, we're still going to use maths to find this 4th highest because we don't have numbers for physics. So, the 4th highest for physics, for maths rather, it's 1, 2, 3, 4. So this is the 4th highest. This is the 4th highest, which is equals to 87%, right? So remember that we are having 85% for maths. We want to know the highest, the 4th highest in physics. So we can really assume that the highest is just either here at Q3 and above. So it's between the 100 and Q3, right? Which is between 70 and 100. So I'm just going to take this 100. So meaning that the highest from maths, which is 87% minus Q3, which is 70%. So it's going to be 87% minus 70%. It's going to give us 17%, which is the highest difference of these marks. So basically this means now that physics mark of this learner is 70%. Okay guys, so now I'm going to do question 2. So I won't read the entire statement. please read it on your own. But what we have in a nutshell is we are having a top 10 maths learners, which their marks were recorded at a certain time. So this is the time, and these are the marks of these learners, right? So below is a scatter plot of the marks and the time, the average time. So in 2.1, it says that calculate the equation of the least squares regression line, right? We all know the least squares regression line, right? So for us to find that equation, which is y is equals to a plus bx, right? So this is the equation of the regression line. So you need to punch these values here, these values in this table here. So this average time would be your x, this learner marks would be your y, right? So these are the instructions that I just wrote for you to really find the regression line. So you're going to use your normal calculator, your normal casual calculator. If you're using a different calculator and you want me to really explain how to find this, please hit that comment in the comment section below. Just write, inform me which calculator you're using and you need help with this thing, and I will explain. So in a normal calculator, casual calculator to be specific, the first thing you're going to do is you're going to press mode, and then after pressing mode you're going to press number 2. So you're going to see number 2 there, and then you press it, which would be written start, right? And then step number 3 is you're going to press number 2 there. So in number 2 you will see this equation here, which is the equation of the regression line, right? And then after doing that, you're going to write, so you're going to see a table which is like this. So it's going to be x and it's going to be y, right? So you're going to put in values of x and then you're going to put in values of y, right? So in the values of x you're going to put average time, because that is our that is in the x-axis if you see at the scatter plot. And then in the value of y you're going to put learner's marks. So you're going to punch in all these numbers here that are in the table, this table here, this one here. So you're going to put in all the x values, these are the x values, and then you're going to put in all the y values like that, right? And then once you're done, you're just going to press escape. You're going to press, not escape, sorry. You're going to press AC of your calculator. It's in the big button. It's written AC. So you're going to press that button. And then after that, you will press the following. So you're going to press shift. Right? So you're going to press shift and then you press number 1 of your calculator. After pressing number 1, you're going to press number 5, which will take you to the regression section. And then after pressing number 5, you will see in number 1 you will see an alphabet A. Then you can punch in that number 1 to find the value of A, and then you can punch in number 2 to find the value of B. So you can first punch in the value of A and find the value of A, and then start afresh by punching in shift 1, 5, and then you find the value of B, right? So that is the whole step on finding this equation, right? So the values that you're supposed to get is, the A value is supposed to be 12.41 and the B value is supposed to be 0.485, and then you have to write your equation, right? So the equation is A plus BX, so it's going to be 12.41 plus 0.485x. So this is your equation that is required in this question here. So now 2.2, we are told that a learner completed the exam in 2.5 hours. Predict the mark that the learner will achieve. So for us to find this mark, you know your equation is y is equals to A plus bx, right? Which you found to be 12.41 plus 0.485x, right? So this is your equation that you found in 2.1. So you just need to substitute where there's x, because x represents time. So in this case, you are given 2.5 hours. But you can't substitute 2.5 hours in the equation because the x represents minutes, right? Your average time is in minutes. So you need to convert these 2.5 hours into minutes. So you're going to say 1 hour is equal to 60 minutes, right? But you have 2.5 hours. So it's going to be 2.5 hours divided by 1 hour times 60 minutes. Then the answer that you're supposed to get is 150 minutes. Then you're going to substitute that 150 minutes in this x value here. And your y is supposed to be 85.16%. So this is the percentage for the learner in 150 minutes. 2.3, they say explain within the context why the regression line is not reliable. So remember, the regression line says that we have y is equals to 4 so the regression line says that we have y is equals to 12.41 plus 0.485x, right? Why are we saying this regression line is unreliable? When this is the x-intercept, right? It's 12.41%. So this means now that x-intercept, which means, it's the y-intercept, sorry. It's the y-intercept where x is equal to 0. So 0 time. At 0 time, the learner is supposed to get 12.41%, which is impossible, right? You have to start writing. If you look at the scatter, by the way, of these 10 students or these 10 learners, it doesn't really start at the intercept. So the intercept doesn't really exist in according to this scatter plot, because if you can see here, it starts at 50. The marks start at 50. They don't really appear to have 12.41. So 12.41 doesn't really exist. So it makes the regression line not reliable. 2.4. We are asked to calculate the standard of deviation of the top 10 mathematic learners, right? So remember, this table, use the same table. So the same table where you punched all the numbers following my instruction on 2.1. You use that same table, but now to find the standard of deviation, you're going to say shift and then you press 1, right? And then you press 4, which will take you to the variance. And then the variance that you're supposed to choose is this one of like this, that looks like this, right? In your calculator, you need to choose this one. Why are you choosing this one? Is because this represents population, right? But if you choose this one, it represents samples. So here we're talking of people, so we need this standard of deviation, not this one here. So you're going to choose a standard of deviation that looks like this in your calculator. So your standard of deviation is supposed to be 10.28. That is what you're supposed to get. Constant deviation of the mean. So if the mean is equal to this number, calculate the value of p. So how to solve this problem? We have so to be able to solve this problem, we have the mean, right? And if you subtract the mean with the standard of deviation, you're going to get your value of p, right? The mean we are given is 63.96 minus the standard of deviation that we don't know is equals to p. So let's say this is your equation 1. And your equation 2, you can say the mean 63.96 plus your standard of deviation, which you don't know, is equals to this point here, the point of p, but which is 103.59. So this is your equation 2, right? So let's first solve equation 2 because we have everything. So I'm just going to say 63 here at the top, 0.96 plus this standard deviation is equals to 103.59, right? Transpose the 63 to the other side, you have standard deviation is equals to 103.59 minus 63.96, right? And the answer you're supposed to get here is 39.63 for this one here. And then you go back to your equation 1, where you already have this. Now you want to find the value of p. So you're going to say in equation 1, it's 63.96 minus the standard deviation is equals to p, and then 63.96 minus what's this value here we found to be 39.63. 39.63 is equals to p. So when you subtract these two numbers, you're supposed to get 24.33. So that is the answer for p.
Okay, so now we're going to do question 3. So in this question, we are given point A, which is this one here in the diagram, and point B, which is this one, and point P, which form a triangle, so which is this one here. And we are told that BP is equals to AP. So this side of AP is equals to BP, right? And another thing is we are told that E is the midpoint of AB. So now, question 3.1, we are asked to find the coordinates of E. So we know very well that E is the coordinate. We know very well that E is actually the midpoint of AB. So we're going to use the coordinates of A and B. So having the coordinates of A being 5 and 0, and B being 7 and 6, and E is the coordinates of these 2 points. So we're going to first find the x coordinates of E being equals to the x coordinates of A plus the x coordinates of B divided by 2, right? And then equals to, so the x coordinate of A is this one here, which is 5 plus the x coordinate of B, which is this one here, 7 divided by 2, right? So it's just going to get 6. So this is the x coordinate of E. And then the y coordinate of E is equals to the y coordinate of A plus the y coordinate of B divided by 2 equals to, so the y coordinate of A is this one here, which is 0, plus the y coordinate of B, which is 6, divided by 2 will give you 3. So these are the coordinates of E. So E coordinate is going to be 6 and 3. So now 3.2 says that determine the equation of BA. So here is the line of BA or AB, this one here. So we're going to use these 2 coordinates to find the equation of AB. So we have our coordinate of A being equals to 5 and 0. Right, and the coordinate of B being equal to 7 and 6, right? So to find the equation of these 2 points, let's first find the gradient of AB, right, which is y2 minus y1 over x2 minus x1, right? So let's say this is going to be x1, this is y1, and then this is x2, this is y2, right? So meaning instead of writing y2, we're gonna write 6, this 6 here because it's y2, and then y1 is this one here, so it's minus 0, divide by x2, it's this one, so it's 7, minus x1, which is this one, is 5. So your gradient here is going to be 3 if you punch your calculator. So now you have your gradient. So equations y is equals to mx plus c, but our m is equals to 3, so it's going to be y is equals to 3x plus c. So you're going to substitute any point. It can be point of A, which is 5 and 0, into this equation to find the value of c, right? So where we see 5, where we see x rather, we're going to put 5, and when we see y, we're going to put 0. So it's going to be 0 is equals to 3 into 5 plus c. So 0 is equals to 15 plus c, and then we transpose the 15 to the other side. Therefore, c is equals to minus 15. So our equation is going to be y is equals to 3x. Instead of writing c here, we're just going to write minus 15. So this is our equation of AB. B. So now 3.3 says that line BA is parallel to the straight line which has this equation here. So calculate the value of R. So what we need to know is this line of BA is parallel to a straight line. We don't know in according to the diagram, but we know the equation of the straight line, which is this one here that is given, right? So and another thing that we need to note is parallel lines have equal gradients. So the gradient of AB or BA is equals to the gradient of this straight line, right? So we know very well that the gradient of AB that we found in the previous question, it was 3. So meaning the gradient of the straight line is also 3, right? So we're going to use that information later on to find the value of R. Rx minus 3y plus 5 equals to 0, right? And then we're going to write it in standard form so that we will be able to see or be able to calculate this R, right? So to write it in standard form, we're going to transpose this part here to the other side. So you're going to have minus 3y and transpose this one, so it's going to be equals to minus Rx minus 5, right? And then we divide by minus 3 all sides, divide by minus 3. So y is going to be equals to this negative Rx over minus 3 minus 5 over minus 3, right? So it's going to be y is equals to, so the negative goes away. We have Rx over 3 minus, or the negative also goes away, so it's going to be positive 5 over 3. So you have this standard equation that we have here, and you need to note that the gradient of AB is equals to the gradient of this line here, of this equation here. Let me just write line, which is equals to 3. So what defines a gradient in a straight line? Y is equals to mx plus c, right? So this is the gradient, right? So meaning in this case our m is equals to r over 3 in terms of this equation here, r over 3, of which we know that this r over 3 is equals to the 3 here, this gradient here. So to find the r, we're just going to cross multiply. So it's going to be r is equals to 3 times 3, which is equals to 9. So this is the value of r. So now 3.4, we are given an area of triangle AOP, which is equals to 10 units squared, and we are told that y is less than 0. So whatever value of y that you're going to find in this question is to be less than 0. If it's greater than 0, then there's something wrong with your calculations. Calculate the coordinates of P. So we want these coordinates of P here, but we are given the area of this portion here. I'm just going to, so even though my triangle doesn't look accurate, but this is, let me just shade it. So this is what we are looking for. We are looking for the coordinates of P, and we are given this area here. We are given this area here. So this is O, this is A, and this is P. So now we're having the diagram, looks more like this one, right? And we have our P here, which is what we are looking for, X and Y, right? As you can see on the diagram here. And we are given the value of A, which is 5 and 0, right? This one here. And we are given the origin, which is 0 and 0, right? So those are some of the information that we have. So the origin is 0 and 0, A is 5 and 0, the area is given as 10 units squared, right? So the first thing is, let's identify the area of a triangle. area of a triangle is half base times height. Right, so we're going to take this as the base. Why am I taking this as the base? Is because this side here is going to be our perpendicular height. Alright, so if we go to our diagram, you'll see what I'm talking about. So this portion here is going to be our perpendicular height. So if this is our perpendicular height, then this, from this point up until this point, is going to be our base of the triangle. This is the triangle, right? It looks like this. So this would be our perpendicular height. Cool. So now we have half. What is our base? It's OA multiplied by our height, which is unknown. So area is equals to, so our area we're given is 10 equals to 1/2. And then our A, since it's from this point up until that point, and we know that the x value of A is 5. So it means now, because it starts from the origin and then it goes to A. So we're just going to write 5 here, multiplied by H. Then we cross multiply. We have 10 times 2 equals to 5H. Divide by 5 both sides. We have H being equals to H being equals to 4 units, right? So our height is equals to 4 units. But remember, that H is actually a y value if you look at it in terms of the diagram. So you can conclude that y is actually equals to -4, right? Why am I saying that? If you take a look at your diagram, and what we just found here is we just found the y value of P, this y value here, which means from this point up until that point, since it's our perpendicular height, it's actually our y value, which is equals to -4, since from this point going downwards it's negative y. Okay, fine. So now we have our y value being equals to -4, right? But we need our x value now. So we need our x value of P. We don't know it. So for us to find that x value, we need to remember the information that we are given. We were told that AB, so this line here, AP is equals to BP. So basically that means now that the distance of BP is equals to the distance of AP. So we're going to write that expression here. So what we have is, we know the formula of a distance is equals to the root of x2 minus x1 all squared plus y2 minus y1 all squared, right? If I write it in terms of distance squared is going to be x2 minus x1 squared plus y2 minus y1 squared, right? So we're going to use this equation here to really find our value of x, right? So we know very well that AP is equals to BP, right? So reason is we were given this statement. So this means now that our value of A, we know it as 5 and 0. Our value of B, we know it as 7 and 6. Our value of P, we now know the y value, which is -4. So we just want this x value. So we're going to write this AP in terms of distance form. So we're simply going to say, we know very well that this distance is actually equals to the root of x2 minus x1 all squared plus y2 minus y1 all squared is equals to x2 minus x1 squared plus y2 minus y1 squared, right? So we're having square root of so this is the square root of AP. This is the distance of BP, right? So we're just gonna remove the square root. So to remove the square roots, we're gonna square both sides, so they'll disappear. We'll remain with x2 minus x1 all squared plus y2 minus y1 all squared equals to x2 minus x1. So let me write this properly. Minus x1 squared plus y2 minus y1 squared. Remember that this is for AP and this is for BP. So let's substitute those values. Let's substitute the value of AP. We know A is given as 5 and 0 and P is given as x and minus 4, right? And this side we know for BP, we know B is equals to 7 and 6 and P is x and minus 4. So you're going to substitute these values in these distance equations, right? So let's say this is actually our x2 and this is x1. So this would be our y2 and this would be our y1, right? Same goes here. Let's say this is x2, this is y1, this is x1, this is y1, right? So this is y2 right there. So we're going to substitute these values according to what I just did. So instead of writing x2 here, we're going to write this 5. It's going to be 5 minus this x1 here, which is x squared, plus, and then our y2 is 0, minus our y1, which is minus 4. So it's going to be minus 4 squared equals to, and then this side here, x2, is going to be this 7 here. So it's going to be 7 minus x1, which is this x here. So it's going to be x squared plus, and then y2 is this one here, which is this, sorry, y2 is this one here. So it's going to be this y2 here, which is 6 minus y1, which is minus 4. So it's minus 4 squared like this. So we're going to have 5 minus x squared plus this negative multiplied by this negative gives us positive. So it's going to be positive 4 squared. Why? Because you have 0 plus 4 is equals to 4 right here inside. And then equals to, we have 7 minus x squared plus, and then 6 minus 4, which is going to be 6 plus 4 squared. All right, so remember we're trying to find the x value of P. So we're going to have 5 minus x squared plus 16 equals to 7 minus x squared plus, so 6 plus 4 is 10 squared. So we're going to have 5 minus x squared plus 16 equals to 7 minus x squared plus 100, because 10 squared is 100. Then we're going to find the product of this and the product of that by expanding. So we'll have 5 minus x plus 16 equals to 7 minus x and 7 minus x plus 100, right? So 5 multiplied by 5 will give us 25, right? And then 5 multiplied by this negative x is minus 5x, and this one here minus 5x plus x squared plus 16 equals to the 7 multiplied by the 7, it's 49. 7 multiplied by negative x, it's minus 7x, and this one also it's minus 7x plus x squared plus 100. So this x squared, because it's at this side of the equation, and this one is on the other side, and they have the same signs. If I take the one to the other side, it's going to be negative, so I'm just going to cancel them out, and we'll remain with 25 minus 5x 6x minus 5x plus 16 equals to 49 minus 7x minus 7x plus 100, right? Let's add these like terms here. So it's going to be 25 minus 10x plus 16 equals to 49 minus 14x plus 100, right? So now we're going to add the like terms for this one and this one. So it's going to be minus 10x plus 14x equals to 49 plus 100, and then you transpose this one and this one to the other side. We have minus 25 minus 16, right? So so here minus 14 plus minus 10 rather, 10x plus 14 is going to give you 4x equals 2. So you're going to add the entire numbers here, and then you'll get 108, and then you divide by 4 both sides. So your x value is equals to 27. So this means now that your coordinate of P is going to be 27, which is your x value, and your y value is 4. So these are the coordinates of P. Okay, so now question 4. In the diagram below, a circle with center B, which has A and B, BP is parallel to the y-axis with point P on the x-axis. So BP, this line here, is parallel to the y-axis, which is this one here. And what's the statement saying again? With P on the x-axis. Okay, cool. And then AS is a tangent to the circle B at A. So AS is a tangent, so this line here from this point up until that point, it is a tangent, right? And we are given point A, which is this one here, is given as -2 and 4, and intersections and intersect the x-axis at S. So the same tangent intersect the x-axis at S, right? And the y-axis at R. AE is a tangent to the small circle, so this AE from this point up until that point is also a tangent, but to the small circle with center D. So there is a center D there, and touches the circle at E. So this tangent touches the circle at E. ORS is equals to 45 degrees. So we are given that this angle here is equals to 45 degrees. Fine, so we're having our two circles here, and we're told all the tangents that lie in these two circles. This is a tangent for the bigger circle, and this is a tangent to the smaller circle, right? Cool. Now, the first question says that we must find the equation of the tangent of AS. So we want to identify the equation of this tangent here, AS, right? So to find this equation here, we already know that this equation has an angle of 45 degrees. So if it's 45 degrees, it's going to be 90, and here it's going to be negative 45, but you can just write add that 45 degrees, just say 180 degrees minus 45 degrees, you're going to get 135 degrees. So which means the angle of this line here, so you're going to subtract this 45 degrees here, meaning this part here from this portion up to this portion, it's 135 degrees. So now we know the angle of inclination of the line of AS is 135 degrees, right? So if you write it properly, it's just this one here. So if we write it properly, this is the angle of inclination, which is 135 degrees. Cool. So for us to find the tangent, we have to use the angle of inclination, which is going to be tan of theta is equals to the gradient, right? So we'll be able to find the equation of AS, and we'll also use the point of A to actually find the equation of the tangent. So to find the equation of AS, we know A, the coordinates of A given as -2 and 4, and we are told the angle of inclination of this line, as we calculated, it's just going to be 135 degrees equals to theta, right? So tan of theta is equals to m, right? So we want to find the gradient. Why? Because the equation of a tangent is equals to mx plus c, right? So we first have to find the gradient, then we'll find the value of c. So it's going to be tan of 135 degrees equals to m, right? So if you punch in the calculator, tan of 135 is going to give you -1, so meaning the gradient it's -1. So you're going to say y is equals to minus x plus c, right? And then you're going to substitute point A of -2 and 4, right? So meaning you have y is equals to minus x plus c, and substituting these points here, you will have where there's y, you put 4, so it's going to be 4 is equals to, where there's x, you put -2, so it's minus into -2, plus c is going to be 4 is equals to negative multiplied by negative, gives you +2, plus c, transpose the 2 to the other side, you have 4 minus 2 equals to c. 4 minus 2 is 2, so c is equals to 2. So the equation of this tangent of AS is equals to minus x, right, because we got m as -1, and plus 2. So this is the equation of this tangent of AS. So now the next question, so we're done with this one here, 4.1. 4.2, we are told that if OP is equals to 4 units, so let's go to OP. This point here, from here to the origin, distance from here to here, if is equals to 4 units, right? Okay, cool. Determine the values of A, B, the center of the larger circle. So we are asked to find the coordinates of this larger circle. If we are told that the distance OP is 4 units, right? So what you're going to do is, since we are told the distance from O to P is 4 units, so it's easier to find the x value, right? Because from here to here, it's actually A according to this center of this circle. So meaning our A value is simply -4, because this is the negative side of x, right? So we already have our A being -4. So now the whole point is to find this value of B here. So to find our coordinate of B, now that we have the coordinate of A being equals to -4, we need to note something here. We have this line of AB, right? And we want to find this value of A here. So we know very well that this AB is perpendicular to this tangent of AS, right? Why are they perpendicular? It's because it's tan perpendicular to radius, right? One of your theorems. So they are perpendicular, meaning that if lines are perpendicular, it means now that the gradient of AB, when you multiply it with the gradient of the line of AS, it must give you -1, right? And we already know the gradient of AS. We calculated it in a previous question, and we found to be equals to -1, right? So if we were to calculate it, so we know the gradient of AS being equals to -1, and we know that m of AS multiplied by m of AB is equals to -1. So -1 times m of AB equals to -1. So you divide by -1, divide by -1, m of AB is equals to 1. So now we know the gradient of AB. Remember, we want to find the value, the y value of B, right, which is the center of the circle. So we know the gradient. So the whole idea of finding the gradient is so that we can use it in the equation of the gradient which is equals to m is equals to change in y over change in x, right? The reason why am I using that is because if we're going to use these 2 points here, we're going to use this point here of b and this point of a, right? And we already know the gradient of these 2 points. So, and we know this value of a, we know this value of, and we know this value of b, of a rather, the x value, and we know this value here. We know all the values here, and we just need this value. So you're simply going to use the gradient to find the value of b. So this is what we're going to do. We're going to say, okay, fine, we have a, which is minus 2 and 4. So this is how we're going to do it. So we have a, which is minus 2 and 4, right? And we have b, which is a and b, right? And we know the value of a, which has found it to be minus 4, since we're given 4 units. So meaning now that we have minus 2 and 4, and we have b, which is equals to minus 4 and b, right? And we just noted that the gradient of ab is equals to 1. So if we use the equation of a gradient, which is equals to change in y over change in x, equals to y2 minus y1 over x2 minus x1, right? And we know that the gradient of ab is 1, so it's 1 is equals to, so the y2, we can simply say y of b minus y of a over x of b minus x of a, right? The y of b is this one here, which is b, the one that we're looking for, right? And minus the y of a is 4, so it's going to be 4 divided by x of b, which is minus 4 minus, and x of a, which is minus 2, so it's going to be minus 2, like that, right? So we know it's 1 is equals to b, and then minus 4 over minus 4, so this negative and this negative will multiply, we have plus 2, right? So it's going to be 1 is equals to b minus 4, so it's going to be 1 is equals to your b value, right? Minus 4 over minus 4 plus 2 is going to be minus 2. Then you cross multiply, you have minus 2 is equals to your b value, right? And minus 4, so you transpose the minus 4 to the other side, you have your b value being equals to minus 2 plus 4. So this means now that your b value is equals to 2, since minus 2 plus 4 is equals to 2. So this is your solution of b. So now we're going to do 4.3. It says that determine the equation of the circle with center b. So remember that we found the coordinates of b, which is a and b, like that, and we found them to be a value is minus 4 and b value is 2. So these are the center coordinates of the circle, the bigger circle. So you need to find the equation of that circle, right? If you take a look, the only thing that we have here is the center and the point. So we have the center, which now b is equals to the a value, which is minus 4 and 2, and we have this point here of a, which is minus 2 and 4. So we're going to use those two information to find the equation of the circle, the bigger circle with center of b. So as I said, we have our coordinate of b, which is minus 4 and 2, right? And coordinate of a, which is equals to minus 2 and 4. So we're going to use this to find our equation. We know the equation of a circle is x squared plus y squared is equals to r squared, right? Inside the x squared, we're going to write x minus b. Or let me just say, since we know our values, so this is the value of x, right? So I'm just gonna say x plus 4, right, squared. Why? Because this x value here, it's x equals to 4, so it's x equals to minus 4 rather. So it's equals to minus 4, meaning when you take this minus 4 to the other side, you have x plus 4 equals to 0. So now it's a factor. So you write it as a factor, hence I wrote x plus 4. Then plus your y value of the center is 2. So it's going to be y minus 2 squared equals to r squared. So for us to find the equation of a circle with center B, we are not complete until we find our r, right? So to find our r, we're going to substitute our point, which is our point A, which is minus 2 and 4, right? So we're going to substitute where there's x, we put minus 2, where there's y, we put 4. So here it's going to be minus 2 plus 4 all squared plus our y is 4 minus 2 all squared equals to r squared, right? So minus 4 plus 2 is going to give you 2 squared plus 4 minus 2 is going to give you 2 squared equals to r squared. So 2 squared is going to give you 4 plus 4 equals to r squared. So 4 plus 4 is 8. So 8 is equals to r squared. So now this is our r, which is r squared is actually equals to 8. So to find or to write our equation now properly, we're going to say x plus 4 squared plus and y minus 2 squared is equals to 8. Why 8? Because this whole portion is equals to r squared. So our r squared is equals to 8. So this would be our equation of the circle with center B. So now we go to 4.4, which says that the equation of the small circle is given as this one here with center D. So it has a center D, the small circle. Write down the equation in the form of this here. So we need to deal with this using completing of the square to actually write the small circle equation properly. So the small circle is this one here with a center of D. So the first thing that we're going to do is we're going to write the equation properly. So it's x squared minus 2x plus y squared minus 2y, right, equals to 0. So what you first need to do here is complete the square. So let's first solve this portion here. It's going to be 1 over 2 multiplied by the b value all squared. So it's 1 over 2 multiplied by our b here, it's minus 2. So it's minus 2 all squared. So minus 2 and 2 will remain with minus 1 all squared, right? So meaning when I have x squared minus 2x, then we're going to plus. So it's going to plus the minus 1 squared, and then we subtract it again, minus 1 squared, right? And then we write our y squared minus 2y, right? So we're going to do the same thing here for the y value now. I'm going to say 1 over 2 times b all squared, 1 over 2 times, what is our b here? It's minus 2, also it's minus 2 all squared. So we're going to have minus 1 squared, right? Because it's negative 2 and the 2 will cancel out. So it means now that we're going to add the minus 1 squared and subtract it again here, minus 1 squared. So the entire equation is equal to 0. So what you need to do is we need to factorize this portion here. So you have x squared minus 2x minus plus 1 rather, because the minus 1 squared will give you a positive. So and then you have minus 1 here plus, so this is plus y squared minus 2y plus 1 minus 1 equals to 0, right? So as I said, factorize this, you're gonna have x minus 1 all squared, and then you have this minus 1 here, you're just gonna write minus 1 plus, and factorize this portion here, you have y minus 1 all squared, and then this one here you write it as minus 1 equals to 0. So you're just going to transpose this minus 1 and this minus 1 to the other side, which is this side here, and you will remain with x minus 1 all squared plus y minus 1 all squared equals to, so the minus 1 when it goes to the other side is going to be plus 1, so it's going to be positive 1 rather. So I'm just going to write it as 1 plus another 1, so because this is negative 1 and negative 1, Going to the other side is going to be positive. So our equation is going to be x minus 1 all squared plus y minus 1 all squared equals to 2. So this is our equation with center D. 4.5 says that write down the coordinates of D, the center of the small circle. So remember that D is actually, in 4.4 we were told that it is the center. The center of D is actually this equation here, right? It has a center of D rather, and we found the equation with the center of D to be x minus 1 squared plus y minus 1 squared equals to 2, right? So we found this equation. So now we want to find the coordinates of D. So it's just simple. We're going to take, because D is the center, so center of this circle here, so you're just going to write this minus 1 transpose to the other side is going to be positive 1. This minus 1 transpose to the other side is going to be 1. When I say transpose to the other side, if you have x minus 1 is equals to 0, so you transpose the negative 1 is going to be x equals to 1. Hence I wrote x equals to 1 here. And then you have y minus 1 is equals to 0. You transpose the minus 1 to the other side, you have y is equals to 1. So hence I wrote 1 here. So these are your coordinates of D, which is 1 and 1. So now 4.6, we are asked to calculate the length of AE, the tangent to circle D at E, right? So this needs us to go back to our diagram. So let me clear our diagram so that we are able to see clearly on what's going on here. So we are asked to find the coordinates of we are asked to find the length of AE, right? So for us to find that length of AE, let's first draw this triangle here. So we're having a tangent that looks like that. So it's the tangent of the smaller circle, and then because we want AE, which is this line that I just drew, it's what we want. We're having a triangle. I'm going to form a triangle that we're having here. So you're having this, and it joins there. So what you need to note is this triangle is, so this triangle that I just drew has a right angle here. Why? Because tangent is perpendicular to radius, right? So it is a tangent. So our AE is what we are looking for, this side here, the distance, but we know DE. Remember, we just found we know DE to be what? We just found our equation of the smaller circle being x minus 1 squared y minus 1 squared equals to our r, which is 2, right? So this is the radius, right? DE is actually equals to the radius of the smaller circle. So what's the radius of the smaller circle? Here it's 2, right, which is r squared equals to 2. So to find the radius, we square both sides, so r is equals to root of 2. So it means now that DE is actually equals to root of 2. So this is equals to DE. So it's the length of DE. So we have this length to be equals to root of 2, right? And the length of AD now, we need to find that. So for us to find the length of AD, we know the coordinates of A, we know the coordinates of D. So let's find the length of AD. Once we find the length of AD, we're going to use Pythagoras theorem to find the length of AE. So let's do this on the other side. So we know the coordinates of A being equals to, if we take a look, it's minus 2 and 4. So the coordinates of A is minus 2 and 4, and the coordinates of D it's 1 and 1, right? And as I said, if you draw the diagram, it's like that. It's like that. So your A is here, your D is here, and your E is here, right? We're looking for this side. We know it's right angle here. This is root of 2. We want to find the distance from this point up until this point. Let's first find that. So the distance of AD is equals to the root of So let me write it properly. The root of x2 minus x1 squared plus y2 minus y1 squared. So this would be your x1, this is y1, this is x2, this is y2. So I'm gonna write that inside here. So it's going to be equals to the root of x2 being equals to this one here. So it's 1 minus x1, it's this negative 2 here, so it's going to be negative 2 like that, all squared, plus your y2 is this one here, which is 1 minus this 4 here, so it's 4 squared. So it's equals to the root of minus 2 times minus 2 is positive, so it's 1 plus 2 all squared, and plus 1 minus 4 squared like that equals to the root of 3 here squared plus into minus 3 squared, right? So you're having the root of 3 squared is 9, so it's 9 plus 9 being the root of 18, right? So this is the distance of AD, right? 18 units. So now we just calculated the distance here, which is 18 units. So now we want to find this distance here of AE. So we're just simply going to use Pythagoras theorem, r squared equals to x squared plus y squared, of which our r squared is equals to AD squared equals to, and then our x, we're going to take the DE squared plus our AE squared, which is what we're looking for. So AD is equals to root of 2 all squared is equals to our so AD, which is this side that we just calculated, this one here, is equals to root of 18, right? So it's going to be root of 18 all squared equals to our DE, which is what we know here, being root of 2 squared plus AE squared, which is what we are looking for. So we can first find the answer. The root of 18 all squared is going to give you 18 equals to the root of 2 all squared is going to give you 2 plus AE squared. Transpose the 2 to the other side, we have 18 minus 2 is equals to AE squared, which you'll get 16 equals to AE squared. And find the square root of this, you're going to have AE being equals to 4. So you're going to have AE being equals to 4. So it's plus or minus 4, but because we are looking for a length, we're just going to take a positive sign. So it's 4 units. So this is the length of AE. We're going to do this question 5. 5.1, we are asked to calculate the value of this expression here without the use of a calculator. So this problem here, you are supposed to get it right because you can simply punch a calculator and get the answer, right? But we are to solve it without the use of a calculator. So meaning, before you even solve, you can punch it in a calculator and see if the answer would be correct when you start solving, right? Okay, fine. So now let's start solving this problem. So we're having 1 minus 4 sine squared of 15 degrees, right? What we need to note here is this is one of our double angle formulas. So if you use cos of 2x is going to give you 1 minus 2 sine of squared of x, right? And which can also be written as, so let me say, and can also be written as cos of 2x. So we transpose the one to the other side, it's equals to, so it's going to be minus 1, right? If you transpose the one to the other side, minus 1 is equals to minus 2 sine of 2x. So this is one of the double angle formula. So you can write it like this, hence I wrote 1, or you can write it like this, hence I wrote 2. So that's how we're going to approach this problem here. So meaning we're having 1 minus 4 sine squared 15, right? We can simply write as 1 minus 2 sine squared 15 minus 2 sine squared 15 degrees, right? So this portion here of the problem is this one here. It's similar to this, right? So which means instead of writing this, you're going to write this cos of 2x, right? So let's replace it. So it's going to be cos of 2x for this one, and then this expression here, which is minus 2 sine squared 15, is going to be this one, right? Which is cos of 2x minus 1. You see, it's similar to this one. So you're going to write cos of 2x minus 1. So that's how we can approach this problem. So now we're going to write this expression here now. We're going to say cos of 2 into, so instead of writing x, we're going to write the 15 degrees. So it's going to be 15 degrees. And then instead of writing this expression of minus 2 sine squared 15, we're going to write this one. So it's going to be plus cos of 2 into, so instead of writing x, we write 15 degrees minus 1. So now we've simplified our problem now into this expression here. So we're going to multiply the 2 inside here and also here. So we're going to have cos of 2 times 15 is going to give you 30. So it's 30 degrees plus cos of 30 degrees minus 1, right? So now cos of 30 degrees plus cos of 30 degrees minus 1. So the cos of 30 degrees will give you root of 3 over 2 if you know your special angles, plus root of 3 over 2 minus 1, right? So we're just going to add these and this. You're going to have 2 root of 3 over 2 minus 1. This root of this 2 will cancel out with this 2, and then you remain with root of 3 minus 1. So this is going to be your solution of this problem here, root of 3 minus 1. 5.2, we are asked to simplify the following without the use of a calculator. So with such problems, I really don't appreciate students who get it wrong, because you already know the answer before even starting to solve this problem, right? So what do I mean by that? If you have an expression without the values of x, you can simply punch it in your calculator and you will know the answer that you need to expect when you solve the problem. So you're just going to solve and make sure that you don't make mistakes. And if you made a mistake and it doesn't equals to the answer that you got, then you know you made a mistake somewhere, right? So with this one, because we're having this expression here and it has x values here, so you can't just punch it in your calculator, right? So what I suggest you do, just let x being equals to maybe any special angle, just use 30 degrees or 60 degrees, you know, or 90 degrees. Just use any angle actually, substitute it in where there's x, substitute it and just punch the whole problem inside your calculator. And the answer that you're supposed to get when you punch your calculator, you are supposed to get -1, right? So which means as you solve, you know very well that the answer that you need to get at the end is -1, right? Sometimes it doesn't necessarily mean it's -1. What do I mean by that? Let's say, for example, you have an expression of sine of x towards the end. Let's say towards the end, this is the answer, right? So which means you need to substitute this value, because you substituted this value initially and it gave you this -1. You're going to substitute it again towards the end and say sine of 30 degrees and see what answer it's going to give you, right? And then that will tell you if the answer that you got initially and the answer that you're getting when you substitute this degree of 30 is the same, which means the solution of sine of x is correct. So I hope you understand what I mean by this. If you don't, please comment down below in the comment section and ask me. I will respond to your questions. But anyways, let's just solve this problem here and simplify it into the simplest form without the use of a calculator. So we're having root of 3 multiplied by sine of x multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3 multiplied by cos of x minus 90 degrees. Then we divide by tan of 120 degrees multiplied by sine of x, right? So what I can see in this problem here is we can eliminate sine of x. If you look here, there's sine of x, and this expression here can change into sine of x. What do I mean by that? Cos of x minus 90 degrees, we can write it as cos of, so we want to write it as 90 minus x, right? Which means we have to put a negative here, right? So we know a cos of a negative is actually positive, right? So we'll simply have cos of 90 degrees minus x, and this one here, because it's cos of 90, it's going to change to sine, and it's in the first quadrant. It's 90 minus x, so it's going to be sine of x. So this expression here is just going to change into sine of x. So now we know, if we replace it with sine of x, we're just going to say root of 3 multiplied by sine of x multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3 multiplied by sine of x, right? Divide by sine of x multiplied by tan of 120 degrees. So let's factorize this sine of x and just eliminate it from this expression here. So we're going to have sine of x into the root of 3 multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3, right? And then we divide by sine of x multiplied by tan of 120 degrees. So the sine of x will divide out, then we remain with this other expression here. So another thing is, if you're having tan of 120 degrees, so if you reduce it, it's going to be tan of 180 degrees minus what? Minus 45 degrees, right? So another thing we have, another thing that we need to note now is we're having tan of 120 degrees here at the bottom. So if we were to reduce this problem here, if you have tan of 120 degrees is equals to tan of 180 degrees minus 60 degrees, right? And you have tan, so because this is in the second quadrant where sine is the one that is positive, so it's going to be negative tan of 60 degrees. So if you know your special angles, negative tan of 60 degrees is equals to negative root of 3, right? So that is the solution. So now we know that the solution of tan of 120 degrees is actually negative root of 3, right? So what we need to do now is we need to eliminate this root of 3 because it's common in most of this part of this problem, right? So we're just going to first put this root of 3 instead of tan of 120. So you're going to say root of 3 multiplied by sine of root of sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3, right? Divide by root of 3, which is negative. This is what we got here. Then let's factorize this root of 3 and eliminate it. So root of 3 into sine of squared of 72 degrees plus sine of squared of 198 divide by negative root of 3. Then this root of 3 will cancel out, so we'll remain with negative. So it's going to be sine of squared of 72 degrees plus sine of squared of 198 degrees divide by negative 1, right? So now what we need to do is this: we need to reduce both the sine of 72 degrees and the sine of 198 degrees. So to reduce this problem, we need to reduce it into let me just say the same angle. For example, we have sine of squared of 72 degrees, right? To reduce this, we'll simply say sine of, we can use 90 degrees, right? 90 degrees minus 18 degrees, and then it's squared, don't forget. So 90 degrees minus 18 degrees is going to give you cos, because this is sine, so it's going to change to cos of 18 degrees. Why the cos is positive? Because it's the 90 minus 18 degrees is in the first quadrant. Then we reduce the sine of squared of 198 degrees, which is equal to sine of squared of, we're going to use 180 here, so it's going to be 180 plus 18 degrees. It's going to give you 198, right? So this is in the third quadrant, where only tan is positive, right? It's here in the third quadrant, so meaning that the sine is going to be negative. It's going to be sine of 18 degrees, but it's going to be negative, so it's going to be negative angle. So you're going to have sine of 18 degrees, but it's negative, but you know that this thing is to the power squared, this squared here, meaning that it's going to be positive sine of 18 degrees. So this would be your answer for this expression here. So in replace of this sine of squared of 72, you're going to write this cos of 18 degrees, but remember that it is squared. I forgot to put, because it's squared here, it's going to be squared even here. Even here it's going to be squared, because these two, it's outside, the power will multiply any power that it finds inside. So meaning now that instead of writing sine of squared of 72 degrees, you're going to write cos of squared of 18 degrees. And instead of writing sine of squared of 198 degrees, you're going to write sine of squared of 18 degrees. So let's write that out. So here we're going to write this, so it's going to be let me write it in black. So it's going to be cos squared 18 degrees plus sine squared 18 degrees divided by -1, right? So what you need to note now is this expression here at the top is the same as having sine squared x plus cos squared x. It's the same expression, which is equals to 1, right? So this expression is equals to 1. So which means the same thing applies with this one here, because it's sine squared 18 cos squared 18, which is equals to 1. So you're just going to say the top is 1, the bottom is -1. So the solution is -1. So this is the solution of the problem here. We're having 6 sine of x cos of x plus 3 cos of x minus 4 sine squared x minus 2 sine x equals to 0, right? So for us to solve for x, we need to first collect the like terms. If let's say we consider cos of x being the like term of this one, and then this sine of x being the like term of this one, so we solve them separately. So meaning that if this cos is the like term of this, which means this 3 is also a like term here. So we're just going to factorize those two first. So you're going to have 3 cos of x into, so what will remain is 2 sine of x plus the 1, because this expression here is this one, and then we have negative, which is this negative here. The like term, it's going to be this 2 sine of x, so it's going to be 2 sine of x into, so here it's just going to write the 2 sine of x, because this is sine squared, and then we say plus 1, because this expression here is the same as this one, equals to 0. So what I need you to note is that what's inside is the same. So this expression here and this expression are the same, so we're just going to write them as 1. So you're just going to say 2 sine of x plus 1. So this is just going to be one expression, and then you're just going to put this one on its own bracket. So it's going to be 3 cos of x minus 2 sine of x, right, equals to 0. So now we have this expression here. Remember, we want to solve for x, so meaning this first expression remember I want to solve for x. So this first expression here, we're going to say 2 sine of x plus 1 is equals to 0, or 3 cos of x minus 2 sine x equals to 0, right? So we're going to transpose this one to the other side. You have 2 sine of x equals to minus 1, or here we could just going to transpose the minus 2 sine of x, going to be 3 cos of x equals to 2 sine of x, right? And then here we divide by 2 both sides, so you have sine of x equals to minus 1 over 2, or here we're just going to divide by sine, so here we're just going to divide by cos, right? Divide by cos of x, divide by cos of x will remain with 3 equals to 2 tan of x, because sine of x over cos of x is tan of x. And then remember we want to solve for x, so we divide by 2, so you have 3 over 2 is equals to tan of x. So now we're having these two here, we still haven't solved our problem. Remember, we have to solve for x. So to solve for x for this expression here, we're just gonna find the inverse. So it's gonna be x equals to sine of to the power minus 1 of minus 1 over 2, or this expression here we're gonna divide by tan, so it's gonna be x is equals to tan of 3 over 2. So remember, this sign here, it's negative, here it's negative, but I want you to punch a positive. Don't put the negative in your calculator. So what I want you to define this negative as is it will tell you where sine is negative, because this expression is sine and we are having a negative number here. Where is sine negative? It's negative here in the third quadrant and the fourth quadrant. So those are your angles that you're going to use in the third and fourth quadrant. What do I mean by that? Theta plus 180 degrees is what you're going to use, or theta or you're going to use 360 degrees minus theta. So these are the angles you're going to use for this expression, because that's where your sine is negative, right? So but before we do that, let's first find the reference angle for this one. So the reference angle is going to be x equals to, so sine of 1 over 2 is going to be 30 degrees, right? So this is going to be your reference angle, right? And then here arctan of 3 over 2 is going to give you 56 point, so it's going to be x equals to 56.31 degrees, right? So this is going to be your reference angle. So please note that the reason why we're going to continue to find other values of x is because in this problem we are not given a restriction, so we're just going to continue until we finish. So as I said, these are the angles you're going to use: 180 plus theta and 360 minus theta, of which your theta in this case is going to be your 30 degrees, which is your reference angle. So x will simply be equals to that 180 degrees plus theta, which is equals to 180 degrees plus the 30 degrees, right? So your x value in this case is going to be 210 degrees plus 360 degrees of k, right? So this is the first solution, and then the second solution is this one. You're just going to use this one. We're going to say x is equals to, so you're going to write your 360 degrees minus theta, which is actually 360 degrees minus your reference angle of 30 degrees. So your x value is going to be 330 degrees plus 360 degrees of k. So this is your solution of x for this side of the problem. So now coming to this one where the reference angle is 56.31, how do we find these angles here? Theta plus 180, whatever. So we look at our tan. So our tan in this case is tan, and it has a positive value of 3 over 2, right? So where is tan positive? So you go to your Cartesian plane, it's positive here in the first quadrant, it's positive here in the third quadrant. So here the angle is 180 degrees plus theta, right? and here it's 90 degrees minus theta, or 360 degrees plus theta. So those are the solutions that you are looking for, right? So what you're simply going to do is this: you're going to say, okay, fine, I'm going to use 180 degrees plus theta, right? So meaning it's going to be x being equals to 180 degrees plus theta, of which your theta in this case is 56.31. So it's 180 degrees plus 56.31 degrees. So your solution of x for this problem here is So your solution of x is going to be 236.31 degrees, or another solution is going to be equals to your 90 degrees minus theta, right? Which is in the first quadrant. So x is equals to 90 degrees minus 56.31 degrees. So you're going to get 33.69 degrees. So these are your solutions of x. It's going to be this one here, and so you're gonna say plus 180 degrees of k, because tan has a period of 180, so you're gonna use 180 plus 180 degrees of k. So these are your solutions of x. So now we're going to do 5.4, and we are asked to prove that the left hand side is equals to the right hand side. So to solve this problem, let's use the left hand side to prove that it's actually equals to the right hand side. So we're going to choose the left hand side. The left hand side that we just chose is 1 minus tan of a into brackets multiplied by cos of a over cos of 2a, right? So this is the left hand side, yeah? And the right hand side that we are trying to prove to be equal to is 1 over cos of a plus sine of a, right? So you're just going to use this left hand side to solve the problem. So what you're going to do is you're going to first change this tan into 1 minus sine of a over cos of a. So that's one of the identities, multiplied by cos of a over cos of 2a, right? What I need us to do is to solve this 1 minus sine of a over cos of a. So by actually finding the common denominator, which is cos of a, and we know this one is over 1. So 1 goes how many times into this one that can't be seen? Goes 1. So we have cos of a minus this cos goes once in cos, so you have minus sine of a. So this expression here, it's actually equals to this one here, right? And let's deal with this one here. So we have cos of a over cos of 2a. So if you write it, we're going to write cos of a over, so cos of 2a is the same as cos squared a minus sine squared a, right? So you're simply going to write that cos of squared a minus sine squared a, right? So now I've written two expressions, this one here and this one here. So let's multiply both, because this expression is equals to this one and this is equals to that one. So let's multiply these expressions. So we have cos of a minus sine of a divided by cos of a. So here we put brackets multiplied by cos of a divided by cos of squared a minus sine squared a, right? What we can see is that this cos of a will divide out with this cos of a, so you will remain with cos of a minus sine of a over cos squared a minus sine squared a, right? Another thing that I need you to know is that at the bottom, this is the difference of two squares, right? If maybe you have x squared minus y squared, to factorize this, you'll have x plus y and x minus y, right? So you're going to do the same thing here to factorize. So you will have cos of a minus sine of a divide by cos of a, you put the bracket there, cos of a, and then here sine of a, and then here sine of a, and it's going to be plus and minus. So the minus will divide out with this minus, and then you'll remain with 1 over cos of a plus sine of a. So this is equals to the right hand side. So this is the right hand side, if you remember clearly. So therefore this confirms now that the left hand side is actually equals to the right hand side. So now we're going to do 5.5. We are given this sine of 2 theta is equals to k, and we are told that 2 theta lies between 0 degrees and 90 degrees. So we are already told that it's in the first quadrant. And 5.1, we are asked to find cos of 2 theta, right? So what we know is that we're having sine of 2 theta is equals to k, and we are told that 2 theta lies between 0 degrees and 90 degrees. So when we're given this expression here, you need to first draw it in your Cartesian plane, right? Because we are told that 2 theta lies in the first quadrant, so it's 2 theta, and because it's sine it's opposite over hypotenuse, right? So the opposite of these 2 theta, it's this one here, which is going to be equals to your k, and it's divided by 1, so meaning here it's going to be 1, which is your hypotenuse side, right? So if I write that 1 properly, so it's going to be 1. And then we want to find this side here. So to find that side, you're going to say r squared is equals to x squared plus y squared. Our r is 1, so it's going to be 1 squared equals to our x, we don't know, plus our y is k squared. So it's going to be 1 equals to x squared plus k squared. Transpose the k to the other side. X squared is equals to 1 minus k squared. Then you put your square roots. So x is equals to the root of 1 of the root of, so x is equals to the root of 1 minus k squared, right? So here it's going to be root of 1 minus k squared. So now we are asked to find cos of 2 theta, right? Which this is 2 theta, but cos is actually equals to adjacent side over hypotenuse, right? So what's the adjacent side? The adjacent side is this one here, which is root of 1 minus k squared, and the hypotenuse side is 1. So this would be the solution of this problem here. And then 5.5.2, we're given this expression as to solve by determining it in terms of k, right? So to solve this problem here, we're having sine of 2 theta over tan of theta, right? So to solve it, let's first expand this. So it's going to be 2 sine of theta cos of theta, right? If you know your double angle formulas, this is one of them, over tan of theta, right? And this is divide, so it means now sine, it means, so this means now 2 sine theta cos theta divided by tan theta, which is equal to 2 sine theta cos theta times 1 over tan theta, of which tan theta is equals to sine theta over cos theta. So it's going to be 2 sine theta cos theta divided by sine theta over cos theta, right? Which would be 2 sine theta cos theta multiplied by cos theta over sine theta. So this sine will cancel out. We have 2 cos theta and cos theta is going to be cos squared theta, right? So this is the expression that we're getting here, right? But what you need to note is this one here. We said when you have cos of 2 theta in the previous question, it's equals to root of 1 minus k squared, right? And to change this, you know it's a double angle, so you can have cos squared theta minus 1 also equals to this expression of 1 minus k squared, right? Here it's 2, right? So it's 2 cos squared theta minus 1. And if we transpose this one to the other side, we'll have 2 cos squared theta is equals to root of 1 minus k squared plus 1. So if you have 2 cos squared theta, this is the solution that you'd be looking for, of which this is what we got here, 2 cos squared of theta. So which means the solution for that, it's this one here. So you're simply gonna write the root of 1 minus k squared plus 1. So this is the solution of this problem here. Okay, so now we're gonna do question 6. Says that in a sketch below we are given the graph of f of x and the graph of g of x, and this is the restriction from minus 180 to 180 degrees, and we're also given a point of intersection between both graphs. So 6.1 says that we must write down the value of a and d. So if you look, we're having f of x and the value of a, it's this one here. So any value that is before your trig ratio is called an amplitude. So a is an amplitude. So for us to find a, we're going to look at the amplitude of f, right? So if you take a look, this is the highest point of f, this is the lowest point of f, right? So to find this value of a, you're gonna say a is equals to the highest point of f, the value of y is what? It's 1, plus the lowest point of f, it's negative 1, but you're just gonna write 1 divide by 2 is equals to 2 over 2, it's equals to 1. So the reason why we're writing 1 instead of this negative, is because we want to identify the amplitude, the height between this point and this point. So we are adding both heights and dividing by 2. So hence the value of a is equals to 1, and it's not negative here, it's just positive. Now we want to find the value of d, which is this one here in our g of x. So if you take a look, so this is our g of x, this one here, and this g of x starts at 1 and ends at 180, right? What I need you to note is the normal graph of g of x. If you have y is equals to cos of x, for example, the graph will start here and it will move down and it will end here. So let me just fix the graph. So it will start here. So the graph will start here and will end here. So what this means is it will end at 360, right? And the height here is 1. And then this point here would be your 270 degrees. And this would be your 180 degrees, and this would be your 90 degrees, right? So what I want you to look at is where the graph ends. The graph ends at 360, and the normal value of x when it's 360, sorry, the normal value of x is 360, right? Where the graph ends. But according to this g of x, it ends at 180. So it means that the normal value of x was divided by 2. For us to find d, we say d of x is equals to the period. of the graph. So the normal period is 360, but because this current period is 180, so which means now that the d value, we divided the normal period of 360 by 2 to get 180, which is the current period of this graph here. Hence I say d would be equals to 2. So now 6.2, they say determine the coordinates of d. So what you're going to look at is this coordinate of d here. For us to find this coordinate, because we can't really tell at which value of x this coordinate is at, but we can tell the value of y, since the value of a is in line with the value of d. So we know that the value of y of d is equals to 1 over 2. You just want the value of x of d, right? So for us to find it, since a is in line with d, and we see that here it's 45 degrees, but here x value is minus 30 degrees, right? Let's find the difference here, which should be the same or equal to this difference that exists here, right? Difference between this point and this point should be equal to the difference between this point and this point, right? So if you subtract 30 degrees, say 45 okay, so if you say 45 degrees minus 30 degrees, you'll get 15 degrees. So it means the difference between this point and this point is 15 degrees. So the same applies here, 15 degrees. So it means now that for us to find the value of d, let me clear this up. So for us to find the value of d, we need to add it from the 35, and the value of d comes here, right? So we need to say the x value of d is equal to, so the minus 135 degrees minus the 15 degrees, which is the difference, right? You're gonna get minus 150 degrees. So this concludes now that the coordinates of d would be minus 150 degrees and 1 over 2. So now we're going to go for 6.3. 6.3 says that determine the values of x for which 6.3.1 the graph of f decreases at this period of minus 180 to 180 degrees. So we're going to look at the graph of f. So let me clear this up. So if you take a look at the graph of f, which is this one here, right? We want to know where it's decreasing. So if you check the graph here, it's increasing. The graph of f is increasing, and then this point it's 0, and the graph here is decreasing, right? So this is where the graph is decreasing. So it decreases between these 2 points here. Between these 2 points, the graph is decreasing. So what are the values of x when it decreases? So if you check here, it's minus 90 degrees, so that's the value of x, and here it's 90 degrees. So this concludes now that the graph decreases at x lies between minus 90 degrees, which is this point here, which is this one here, and 90 degrees, which is this point here. So the graph decreases between these x values, which highlights this point of the graph. So this is your answer. So now 6.3.2 says that when you multiply the graph of f and you multiply the graph of g, and it gives you the solution of y, which is less than 0, meaning it's negative, right? So the sign is negative. We want to identify the value of x, but have a look at that in between 0 and minus 180 degrees. So it means now that we want to know the value of x when the value of y multiplied with another value of y gives you a negative. But we are asked to look at 0 degrees up to minus 180 degrees. So we're going to look at this side of the graph. We want to know 2 points. When you multiply them together, they give you a negative solution of y. So this is graph of f, and the graph of f here is positive. The y values are positive here. They are positive, positive, positive. Why am I saying they're positive? Because from the origin going up, the graphs, the y values are positive. So hence I say they are positive, 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 positive here. And then when you look at the graph of g, the y values here are positive, 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 and then here they are negative, 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 negative. So they're negative here, and then they are positive here, right? So now the question says that when you multiply the graph of f and g, it gives you a solution which is less than 0. Less than 0 meaning negative solution. So where can we multiply both graphs and they give us a negative solution? So if you multiply a positive multiplied by negative, it gives you a negative. So let's look at those situations where we have a positive and a negative. So take a look at this portion here. It's positive. This portion of the graph is positive. So if you were to multiply with this portion here, positive multiplied by a negative, it gives you a negative solution. So that's where this happens, right? When you multiply the graph of g and the graph of f, gives you a negative solution. Even here, if you take a look here, the positive will multiply this negative here, and it will give you a negative solution of y. So what are the values of x when this happens? So the values of x, if you take a look, we are between minus 135 and minus 45. So between minus 135 and minus 45, the negative will multiply this positive, giving us a negative solution. This negative will multiply this positive to give us a negative solution. So we can conclude and say x, sorry, so you can conclude and say x must lie between this minus 35 and this 45 here. So between minus 135 degrees and minus 45 degrees, that is where this happens. So now we're given this case here where a figure has km, which is a vertical flag. We are told km is a vertical flag, so you can see here this is km, is set in the center of two circles which lie on the same horizontal plane. So mkn is equals to mlk, which is x, right? So as you can see, this x value here is the same as this x value there. And then the radius of the inner circle is equals to r units, and the radius of the outer circle is 2r. So we are given all of that information. Now we are asked to calculate in 7.1 the value of x. So if you take a look at this graph here, and we just look at this triangle that I'm highlighting here. So this one here, right? So if we look at that graph, because we want the value of x, the value of x is this angle here of x degrees, right? So to just write the expression using this triangle, so we're going to say triangle KLM, which is the triangle that I just highlighted, and the angle it's x degrees, and this dimension of KM we don't have, this dimension of LM we have, right? So we're going to say, when you say tan of x degrees, it's equals to, tan is opposites, opposite is km over adjacent, which is lm, but lm we know it's equals to r. So tan of x degrees is equals to km over r. So to write km, we're gonna say km is equals to, so we cross multiply r tan x degrees. So this would be expression 1. So why am I doing this is because the aim is to find this value of x, this angle. So I'm going to use another triangle. So I'm going to use this triangle here because it has the angle of x, right? So it has the angle of x. So I'm going to use this triangle here, this one here. So the triangle is KMN. So I'm going to write the same expression using this angle of x degrees. So the x degrees is facing that direction. Here it's going to be 90 degrees because here it's 90 degrees, right? So it's going to be 90 degrees there. And since we also were told that km is a vertical, right? So we're going to say tan of x degrees is equal to, so the opposite side, it's mn over the adjacent side of the angle is km, right? This side here. So tan x degrees is equals to mn. We know mn is this side, which is 2r, so it's 2r over km. So you see now that we're having expression of km, and which we used here, so you can equate this equation to km. So we'll cross multiply, and we have km tan of x degrees equals to 2r. Then we divide by tan of x degrees, divide by tan of x degrees. We have km is equals to 2r over tan of x degrees. So now we are having another equation, which is equation 2. So you can simply now say, because we have km and km, so you can equate both equations. We can say equation 1 is equals to equation 2. So equation 1 is this one here. We're gonna say r tan of x degrees is equals to, so equation 2 is this one here. We're gonna say 2r divided by tan of x degrees. And then we're going to cross multiply here, so meaning that it's going to be r tan of x degrees multiplied by tan of x degrees equals to 2r. Then we divide by r both sides, and we will have, so this r goes away and this r goes away. We have tan squared x degrees equals to 2. Then you put the square root both sides. Tan of x degrees equals to root of 2. Because we want this x degrees, so we're going to say x degrees equals to tan of root of 2. So the answer you're going to get is the root, it's going to be x degrees equals to So x degrees is going to be equals to 54.74 degrees. So this is the value of x that we are looking for here. So now we are going to go to 7.2, which says that if you are given r as 5 meters and the angle LMN as 110 degrees, calculate the value of, or the length of ln. So let's look at the diagram that they are talking about. So what we are given here is that where there's r, it's equals to 5 meters. Even here, this r value is 5 meters times 2, right? And we are told to find ln, this side here. So we want to identify the dimension, or the length rather, of this side. So for us to find the length of this side here, we are given this angle to be 110 degrees. So we're having this triangle basically that looks like this. So we're having this triangle that looks like this. This is L, this is N, this is M, 110 degrees, and here it's R, here it's 2R, right? And we want to find this side here. So we know here it's equals to 5, we know here it's equals to 2 times 5, right? So to find this ln, we will use cosine rule. We'll use cosine rule. So ln squared will be equals to lm squared plus mn squared minus 2 lm multiplied by mn cos of m, which is the angle. So we want to find ln, so we're going to substitute here at lm, which is equals to r, so it's r squared plus 2r squared minus 2 into r into r cos of m. So where there's r, we're going to put 5 because r is equals to 5, and then 2 times 5 squared minus 2 into 5, 2 times 5 cos of 110 degrees. So if you punch this in your calculator, you're going to get 159.202. so just write it in 3 decimal, and then you put the square root because it's ln squared, and final answer you're going to get, it's 12.618 meters. So this is the length of ln. So now we're going to do question 8. So we are given a diagram below which has 4 points A, B, C, and D, and we are told that AD is parallel to EC, CB is produced to E, and GD is a tangent to the circle at D, and we are told that DB is equals to AD. Also given an angle of EBA equals to 67 degrees. So this is the diagram we're given here, and we are asked to find the size of angles. So 8.1.1, we are asked to find the angle of ADC. So we want to find this angle here, ADC. So we want to find this angle here. So this angle here is equals to this angle here, right? Why? Because if you take a look, this point here and this point here together with this point and this point, it is a cyclic quad. So the exterior angle of this cyclic quad here is equals to the opposite interior angle, which is this one here. All right, so we can conclude and say it's equals to 67 degrees. So reason is exterior angle of a cyclic quad, right, is equals to the opposite interior angle. Fine. Now 8.1.2, we are asked to calculate the angle C, right? So let me clear this. So C, as you can see, it's just this angle here. So for us to find this angle, we already know this angle here being equals to 67 degrees, right? And want to find angle C, right? So for us to find an angle C, we need to add it with this angle. So what you need to remember is that this side is parallel to this side, right? So meaning that if this angle of 67 and angle C are co-interior, so if you look at parallel lines, this is parallel to this line, so this angle and this angle added together gives you 180 degrees. So it means now that to find angle C, we are going to add this angle of C and the angle of D, of which the angle of D is equals to 67 degrees, and the angle of C we don't know, but we know that the combination of these two gives you 180 degrees, right? So angle C plus angle D is equals to 180 degrees, and the reason you're going to write is co-interior angles equal, or just co-interior angles, just write co-interior angles, and then you can simply indicate that CB is parallel to DA, right? So angle C we don't know, but we know angle D, which is 67 degrees. So the angle D is actually the angle ADC, right? Equals to 180 degrees. Then you transpose to the other side, you have C is equals to 180 degrees minus 67 degrees. Then you're gonna get 113 degrees. So this is the angle of C. Then we go to 8.1.3. So now we want to find angle A, right, which is this one here. So if you take a look, so we said angle C we found to be 113 degrees, and since this is a cyclic chord, if we just indicate with these points, the opposite interior angles, these opposite interior angles must add up to 180 degrees, so they are supplementary. So angle A plus angle C is equals to 180 degrees. Reason, you can say A, B, C, D is cyclic chord, right? Just indicate that the angles are supplementary, right? So meaning we don't know the angle of A, but angle C, it's 113 degrees equals to 180 degrees. You transpose to the other side, angle A is going to give you 67 degrees when you subtract 180 minus 113. So this is the angle A. Now we're going to do 8.1.4, which is we are asked to find angle D2, right? So to find this angle here, this angle D2 here, we need to note something. We already found our A, right? Our A is 67 degrees, and we want to find this D2 here, but we are told that this side and this side are equal, making this angle and this angle equal. So basically here it's also 67 degrees. So this is a cyclic, so this is an isosceles triangle, right? So this triangle here, it's an isosceles triangle. If you have two equal sides, the base angles will be equal. Fine. So so now that we know that, so B, angle B plus angle A plus angle D2, which is what we're looking for, will give you 180 degrees, right? But before you even write that solution, so let me first write it nicely here at the top. So the first thing you're going to do, you're going to say angle A is equals to 67 degrees, right? Angle B2 is equals to angle A is equals to 67 degrees. So you just say isosceles triangle. So it's 67, and then you can simply say angle A plus angle B2 plus angle D2 is equals to 180 degrees. So it's the sum of interior angles of a triangle, right? Angle A we know it's 67 degrees, plus angle B we know it's 67 degrees too, plus D2 is equals to 180 degrees. So D2 equals to 180 degrees minus 67 degrees minus 67 degrees. So the final answer for D2 should be 46 degrees. So this is the answer for D2, angle D2. So now we want to find 8.1.5 angle BDG. So what is angle BDG? Let me erase this triangle here so that we can see clearly. So angle BDG, so angle B, D, and G, right? So we want to find this angle here, right? So for us to find that angle, the first thing we need to do is this. We know that DG is a tangent, right? So meaning D1, this side here, let me use this shaded, it's actually equals to B2, right? So D1 is equals to B2. We know B2 is 67 degrees. So the reason is tan chord, right? So these two angles are equal, and we just found D2 to be equals to 46, right? So meaning here it's 46 degrees, this here. Let me write it nicely. So we know that angle D2 is 46 degrees, right? And we just found that D1 is actually equals to 67 degrees. So basically we just need to combine this angle and this angle to find the required angle of BDG, right? Which is equals to D1 plus D2. And D1 is your 67 degrees plus D2, which is your 46 degrees. It will give you 113 degrees. So this is your final answer. So and then here in 8.2 we're asked to prove that AB is equals to CD. So we are asked to prove that this AB is equals to this CD, right? We're asked to prove that they're equal. So what I need you to note is, for you to prove that they're equal, you need to prove certain angles that they're equal, which are between these two lines, right? So if you take a look, this angle here, D2 rather, is equals to B3. So I'm trying to prove angles that are between these two equal lines of AB and CD. So I'm saying B3, angle B3 is equals to D2. Reason for that is alternate angles. So there's the alternate angles equal, right? Why? Because CB is parallel to AD, right? Fine. So now that I've proven this, it concludes that therefore AB is equals to CD. Then you have to write a reason for that. Can't just conclude, but you need to conclude with a reason. So what I need you to look is this. This angle here of B3 and this angle here of D2, right? We're saying they're equal. So for these angles to be equal, which means their chords must be equal. Remember this where you have let's say you have a triangle like that, and then you have another triangle like that, right? Where we're looking at chord AB, right? Chord AB will produce an angle here. Let's say it's 30 degrees. That angle is going to be equals to the angle that is produced here, which would be 30 degrees. So this chord produce equal angles, right? Or if you remember this, where let's say for an example I say this chord of AB, and then I have this chord of CD. So chord of AB is equal to chord of CD, right? So meaning if they are equal, then they'll produce equal angles here. So same applies with here. We're having this B3, which has an equal angle to D2. So the mere fact that they share equal angles, it means that angle D2 will produce a side of AD, and angle B3 will produce a side of CD. So equal angles, these angles will subtend equal sides. So the reason for this part, you'll say equal angles subtend equal, you can say equal chords, because CD and AB are equal chords. So that's how you prove that AB is equals to CD.
Now we're going to do question 9. So the statement here says that in the diagram below, we have points A, B, and C and D of the circle here, and we are told that OB intersects AC at M and the midpoint of chord AC, right? So, and we're also told that BDC is equals to X. So this angle of D is equals to X, which is this one here. So now we're going to solve the following questions. So 9.1.1 says that we must determine with reasons in terms of X. So now we're going to do A, find the angle of O1. So as you can see from the diagram, this is O1, right? And if you see clearly, I'm just going to mark this point here. So if you see clearly here, you would notice that this is actually Theorem 3, right? Remember, Theorem 3 looks like this, and then it looks more like a kite, and like that, where the angle at the center is twice at the circumference. So the same thing happens here, where this angle at the center, which is O1, is twice the angle at the circumference, which is X, right? So angle O1 is going to be equal to twice X, because the D is actually equals to X, right? This D here, you can call it CDB, right? That angle which is equals to X, you can call it that way. So O1 is equals to 2X. Reason is angle at center equals to twice at circumference. So that is the reason for the first answer here. So now we're going to do the B part of the question. So now we're going to do find the angle of ABO. So now we know that this middle here is 2x, right? This O1, and we want to find this angle here, right? Because we are told it's what? It's ABO, right? So it's ABO. So basically we want to find angle B, which is equals to angle B1 plus B2, right? So we want to find angle B. So for us to find angle B, we first need to identify the angles that lie inside this triangle here. So if you look at this triangle here, we can use this triangle to find angle B. But for us to first use it, we know that here it's going to be 90 degrees, right? And we need to find this angle here, and then we'll be able to find this angle of B, right? So let me erase everything. So now we're simply going to find angle A first, right? We need to find this angle A, then we know angle M is 90 degrees, then we'll be able to find this one here. So if you take a look, I'm just going to draw this here, sorry. So I'm just going to draw a line so that you guys can visibly see when I solve this problem. So I'm going to do this. Right, I hope you can see this theorem. This is angle on the same segment, right? So meaning that this angle here is equals to this angle here, and then this angle here is equals to this angle here, right? So basically, so this means now that angle A1 is equals to this angle D. So I'll call this D2, right, equals to angle D2, right, which is equals to X. So reason for that is angles on same segment, right? Remember, I want to find angle B, which is the combination of these two. So now that we found A1, we're going to use the triangle. So let me erase everything now. I'm going to use the triangle that I'm just going to shade now, which is this one here. So we're going to use this triangle to find B. Alright, so you're going to say in triangle AMB. So now we're focusing on this triangle. We know that A1 is equals to X. M, what is angle M? It's actually equals to 90 degrees. Why am I saying it's equals to 90 degrees? It's because this chord here is perpendicular to this radius here. So it's theorem 1, right? So if they're perpendicular, then it's 90 degrees, right? So that is the reason. So you can write it down. Here you can say radius perpendicular to chord, right? And now we can find angle B, right, which is what is needed. So which you can write as ABO, sorry. So which is ABO plus angle A1 plus angle M is equals to 180 degrees. So this is the sum of angles of interior inside a triangle, right? Sum of angles of a triangle, basically. So meaning, okay, this is 90 degrees, and we know that this is unknown, so we're going to leave it like that. ABO plus our A1 is X plus our 90 degrees here equals to 180 degrees, right? So we're going to transpose these two here to the other side. We will have ABO is equals to 180 degrees minus 90 degrees minus X, right? So this means now that angle ABO will be equals to 90 degrees minus X. So this would be the solution for this question here. Okay, so now I'm going to do 9.1.2. We are asked to prove that AB is a tangent to the circle that passes through ADR. So let's first look at that circle that passes through these points ADR. So let's draw that circle. It will look something like this, and this would be our A point, this would be our D point, this would be our R point. So it's A, D, R, and then the line of AB. So this is A, this would be B, this would be the tangent, and then it will look like this. So basically, we are asked to, for us to know that this is actually a tangent, AB, this angle here must be equals to this angle here, right? So basically, this D, so it's D1 here and A1. So A1 must be equals to D1. Therefore, AB would be a tangent. So that's what we need to prove, right? Because we can't simply say A1 is equals to D1 and tan chord, because we haven't established that as yet. So we need to prove this in a different way, find that possibility as we calculate. So the first thing you can do here is this. We can focus now, let me erase this first. So this is what we're proving, just don't forget, we're trying to prove this. So what we're going to do is this. We're going to underline this triangle here. I want you to see this one here. So the first thing you're going to do is say in triangle BOD, right? We're looking at that triangle. D2, angle D2, which I call this D2, is equals to B2. This angle here is equals to this angle here, right, which is equals to X. So reason for that is because OD is equals to OB. So it's a radii. Or you can just say an isosceles triangle, because this side is equal to this side, therefore the base angles are equal. Cool. And then another thing we can do is, because the whole point here is to make sure that this D1 is equal to this A1. So we're trying to find that out. Please don't forget. So now, what we're going to do is this. So for us to continue doing that, we first have to prove that this is actually 90 degrees here. So how are we going to do that? So let me erase this so that everything is clear. So now, what I'm going to do is this. I'm saying M1 or M2, M1 equals to M2 equals to 90 degrees, right? And I said the reason was that the radius is perpendicular to the chord, right? So hence that is 90 degrees, right? So meaning this is also 90 degrees. So everything here is 90 degrees. Cool. And another thing is this. So remember that I said this is equals to that, right? So the whole aim now, I'm trying to prove that this B2 is equals to this D1. So for me to do that, these two lines must be parallel. So I can't just say they are parallel unless I prove that they are parallel, which is what I'm doing now. So now I know that this is 90 degrees, right? And another thing is this. If you take a look at this line here, this line here, this is a diameter. So DC is actually a diameter, right? Why am I saying that? OD is the radius and OC is the radius. So this is a diameter. And this diameter goes to the circumference like this. So it goes to the circumference. So if you remember clearly, when a diameter does this, when you have a shape like this, and this is a diameter, this one here, therefore here it's going to be 90 degrees, right? Angles on a semicircle. So angle DAC is equals to 90 degrees. Angles on semicircle, right? So this being 90 degrees means this is also 90 degrees, which is what we proved before here. So therefore these two angles are the same, right? They're 90 degrees here, and here it's 90 degrees, making them corresponding angles, right? So once these two are 90 degrees, it confirms now that these two lines are parallel. So therefore OB is parallel to DA. So now we've proven that these two are parallel. So once these two are parallel, then B2 will be equals to D1. Remember that B2 is equals to X. So B2, angle B2 is equals to D1. The reason for that is alternate angles equal, right? So these alternate angles equal, so basically these angles are equal now, and once these are equal, remember that this is also equal to this one here. So since this is X and this is X and this is X, then we are done, because remember we said remember the previous question, we said A1 is equals to X. So A1 was equals to X, and now we just found that B2 is equals to X, of which B2 is equals to A1. I mean is equals to D1, sorry, D1, which is alternate angles, right? So the fact that they are alternate angles, so this is X, this is X, this is X, and this is X. So A1, so you can just conclude and say A1, and A1 is equals to angle D1, and then you write proven above, right? And so once you do this, then therefore AB is a tangent. Why am I saying that? I said initially we need to prove that A1 is equals to D1. Why? Because when these two are equal, and when this is a tangent, then tan chord theorem applies. But we just proven that they're equal without using the tan chord theorem. So therefore, AB is a tangent. So you have to write a reason for this. You have to write tan chord theorem. Right, so next to this solution here, just write tan chord theorem, right? Okay, so now we're going to go to 9.1.3. So we are asked to prove that AD squared is equals to 4DO squared minus 4AB squared plus 4MB squared. So this is a bit tricky. I need you to focus on a triangle that supports Pythagoras theorem, right? Because these everything here is squared, right? So let's look at our shape here. So if you take a look, this is supporting Pythagoras theorem. This triangle here, because it's 90 degrees here, we just proven in the previous question, and also this triangle here. Let me write it nicely. So it also supports Pythagoras theorem. It's 90 degrees here. So you're going to use these two triangles to usually prove what is stated in this question. So if you look at the triangle that is pink, hopefully that is the color, triangle ADC, this triangle here, if you were to write it in Pythagoras theorem, remembering that this is the hypotenuse, it's going to be DC squared is equals to DA squared plus AC squared, right? And the reason for this, you can simply say Pythagoras theorem, right? And then now, you should remember that what we are required to prove, we need to say AD squared is equals to something. So some of these values are not part of the triangle, they are part of the other triangle. So we need to find a way. So the whole point is to find dA, right? So let me just write this in terms of dA. dA squared is equals to DC squared minus AC squared, right? So I want to find the solution of dA squared, as you can see, or AD squared, whatever you call it. So we need to substitute here some of the values. We're having DC squared. Let's look from the shape DC. So DC is from this point up to that point. That is DC, right? And we know that DC is formed by OD and OC, right? And if we take a look at this problem here, there is OD, or you can say DO. So instead of writing DC, let's substitute it and put OD where there's DC. We know that DC is actually formed by twice OD, right? So meaning where we see DC, we're going to put twice OD here. So it's just going to be dA squared is equals to twice OD all squared minus, so AC is this one here. Let me mark it from this point all the way up to that point here, right? So that is AC. So let me just but we know that also AC is formed by AM from here to here. It's AM and MC, right? And then if we take a look, we only have AB and MB, right? But it's wise to substitute AM because, you know, we're still going to use the other triangle. It's just going to be beneficial. So AC is the entire distance from A to C. It's actually twice AM also. So meaning where we see AC, we're going to put twice AM. So it's going to be minus into twice AM all squared, right? So we're going to have dA squared is equals to 4OD squared minus 4AM squared. So now we're having something like this. Let me erase the top. Erase the top. So now that we're having this problem here, it's getting simpler and simpler to solve this problem. So we're having dA squared is equals to 4OD minus 4AM squared. Remember that we are asked to find this problem here, which is AD squared is equals to 4DO squared minus 4AB squared plus 4MB squared. We are asked to prove that this, right? So now we're having AD or dA rather squared is equals to the 4OD squared, which is this one here. So we already covered that portion, but AM is not part of the equation, as you can see here. So there's no AM, so we need to substitute it with something. We know that AM belongs in both triangles. It also belongs to the small triangle, right? So if we were to write it nicely, so this is AM in the small triangle. So if we were to write Pythagoras for the small triangle, we would say AB squared is equals to AM squared plus MB squared. So this is the Pythagoras for the small triangle, right? For the small triangle. So we want to substitute where there's AM because there's no AM in this equation. So we're just going to substitute it there. So we'll say AM squared, transpose this portion to the other side, is equals to AB squared minus MB squared. So when we see AM here in this, we will put ab squared minus mb squared. So we're just going to substitute it here in this am squared. So meaning we will have dA squared is equals to 4OD squared minus 4 into, so AM squared is equals to AB squared minus MB squared. And therefore, final answer, so it's dA squared is equals to 4OD squared, and therefore multiply everything that is inside, so it's going to be minus 4AB squared plus 4MB squared. So this would be your solution for this problem here, which, as you can see, it's similar to what the question required. So that is your final answer. So now in 9.2, we are given this diagram and a tangent LM with a circle, and what's more important is we are told that NQ is equals to WP and NQ is parallel to MP. So for as long as this information is available, in the diagram, then we can simply look at the diagram. But sometimes some information is written here as text and not shown in the diagram. So please just be cautious of that. So 9.2.1. Now we are asked to state with reasons 3 angles that are equal to M2. So we want 3 angles equal to M2. So this is M2, right? We want another angle that is equal to this M2. It is this angle here. So M2 is equals to angle Q, right? It's equal to this angle Q. So the reason for that is alternate angles equal. Why am I saying that? If you take a look, this is the Z, right? So this is the Z. This is parallel to this line. So therefore this angle is equal to this angle. So it's alternate angles equal. Cool. So now that we've proven that these angles are equal, we want another angle. So for us to find, if we take a look at this shape here, this is a triangle. Just going to draw it. It looks something like that. So this triangle, remembering that LM is a tangent, right? This angle here is equals to this angle here. So it's tan chord theorem, right? So we're going to say M4 is equals to Q is equals to M2, right? So the reason for this is tan chord theorem. So now we've proven that M2 is actually equals to Q, which is equals to M2, right? So M4, we just proven that angle, and proven M2, so they are all equal. So now we want the last angle. So if you take a look here, I'm just going to draw the triangle. Take a look at this triangle that is here. It's not accurate, but it looks like this. If you take a look at this red triangle, you'll see that this angle here and the tangent. So it's the tangent, right? And the angle with the chord, it will produce an angle here. So basically what this means is, okay, let me erase this. What this means is M4, angle M4 is equals to W1. So the reason for that, it's also tan chord theorem. So if these two are equal, and you know M4 is equals to Q, which is equals to M, so therefore W1 is equals to M2, right? So we've proven 3 angles being equals to M2. It's W1, it's M4, it's Q. So all three angles, right? So we are done with this question here. Now let's go to this one. It says 9.2.2. Prove that triangle WMV is similar to triangle QMN. Now let me underline, or let me highlight the triangles. Triangle WMV. So there is W, there is M, there is V. So if we draw the triangle, it's going to look like that. And then triangle QMN. So I'm going to do it in red. QMN. So it's Q M N, like that. So it looks like that. So we're going to prove the similarity of these triangles, right? So the first thing we can pick up here is this. As you can see, these triangles. This is a chord, right, which is equal to this chord, right? So I'm just going to highlight the equal chords with a different color. So this chord here that I highlighted with this is equal to this chord here. So the fact that these two chords are equal, they'll produce equal angles. So meaning that it will produce an angle here. So this angle here will be equal to the angle that is produced by this chord, which is this one here. So equal chords producing equal angles. So now this means now that M3 is equals to M1, right? Equal chords subtend equal angles, right? So that's the first thing that is similar between these two. And another thing that is similar is this. Okay, so another thing that is similar is this, in these two triangles, is that this W1 here is equals to this Q here, right? And we've proven that in the previous question. So angle Q is equals to W1. So you can simply say proven. So yeah, now we have two angles that are equal. It's M3 and M1, Q and W1. Fine. And another thing you can see here is this angle V. So this is now the third angle. So if two angles are equal, so we just compare two angles, this angle here and this angle here, this angle here and this angle here. So this confirms now that even though we just compared two angles with reasons that they're equal with each other, which means the third angle of the shapes will definitely be equal. So this confirms now that V1 would be equal to N1 plus N2. So this is just the sum of angles of a triangle, right? So yeah, therefore the triangles are similar. So triangle WMV is similar to triangle QMN. So the reason is we just used angles only to prove that. It's angle, angle, angle. Right. Okay, so now 9.2.3. We are asked to prove that MV over WV is equals to MN over PW. I just want to write that down. Required to prove that MV, so let me write it nicely, over WV is equals to MN over PW, right? So the PW, yes. So you're required to prove that this ratio is equal to this ratio, right? So, but before we solve this problem here, we need to remember that in the previous question we concluded that triangle WMV is similar to triangle QMN, right? So if we were to write this in ratio form, you will say this MV here. Okay, let me use another color. So you'll simply say the MV, which is this one here, you'll divide it with this portion here of MN. So it's going to be MV over MN, right? And then you divide it with what's WV. So you see equals to WV divided with QN. So it's going to be divided by QN, right? So what you will do is you'll cross multiply. So it's going to be MV multiplied by QN equals to WV multiplied by MN, right? And we know that QN, which is this portion here, is equals to PW, right? So it's given is equals to PW. So this is given, right? So where we see QN, we want to replace it with PW. Why? Because the previous question there's PW, right? So it's going to be MV multiplied by PW equals to WV multiplied by MN, right? So let me write it here. So it's going to be MV multiplied by PW is equals to WV multiplied by MN. Now we're going to write it back into fraction form. So meaning we can divide by, because here on our left hand side we have MV, which is this MV, right? It is divided by WV, which is this portion here. So this is multiplication, so we're going to divide by WV, divide by WV both sides. So you will have MV over WV multiplied by PW is equals to MN, right? So we're going to remove this PW because it's at the bottom, as you can see here, and we divide by PW both sides. So we have MV over WV is equals to MN over PW. So this is the expression that is required to be proven in this problem here. Now we're going to do question 10. 10.1 says that you're given a triangle of ABC and the following points, and we are asked to prove the theorem which states that AD over DB is equals to AE over EC. So we are asked to prove the theorem that says that AD over DB is equals to AE over EC, right? So it's AD over DB equals to AE over EC. So this is what we are required to prove, right? So the first thing we're going to do is we're going to construct, right? So we're going to construct a line that goes like that and goes like that, right? And we say it's perpendicular there, and we call this H, right? And then construct another one going that direction and that direction, and we call this K, right? So let me remove this. Ones here. So now, now that we've established our perpendicular heights, let's find the areas. So we're going to find the area of this portion of the triangle at the top, right, with its base being AD, right? And we're also going to find the area of this triangle here with its base being DB. So this is the part that we'll be looking at, right? On the left hand side is this portion here. So at the top is going to be the area of triangle ABC, DE. Divide by the area of triangle DBE. Right? So what's the top area of the triangle? It's half times the base is this one here, which is AD, multiplied by the perpendicular height, which is H. Divide by half this bottom one now, multiplied by the base, which is this side, DB, multiplied by the perpendicular height, which is still H, right? So this cancel out, so we'll remain with AD divided by DB. So this is the first part, right? So now let's do the second part, right? So what we're going to do is this. So we're going to look at the blue line now. So we're going to find the areas of this section here and this section here, basically. So let me just cover everything in this top triangle, because the base is AE. So now what you're going to do is this. We're going to say the area of triangle ADE over the area of triangle DEC, right? Equal to, so what's the area at the top? It's half multiplied by the base, it's this side here of AE, multiplied by the perpendicular height, which is K, divide by half, multiplied by the base here, it's EC, multiplied by our perpendicular height, which is K. So this goes away, so you remain with AE over EC, right? So this is number 2, right? So now we are having the following. So let me just write it nicely on the other side. So we are having the following now, which I labeled as equation 1. We are having AD over DB, right? Equation 2, we are having AE over EC. So these two must be equal. So something must happen for these two to be equal. Let me first erase here. So this is what you need to note. For us to make these two, equation 1 and equation 2 being equal, the following must apply. So let's look at the bottom part. The bottom part, we're having something that looks like this, and we have lines that look like that, and then we have this, we have something that looks like this, right? And then this is the line, and this is the line, right? So you have something that looks like this, and this is E, this is C, this is D, this is B, right? So what you need to notice is these lines are parallel, right? So this is parallel to this one, right? So when you have parallel lines, right, and the shapes, the triangles, this triangle here, the one that I just shaded, this triangle here of DEB is sharing the same base with the other triangle. I'm just going to shade in green. This triangle here, they share the same base. The base is DE. So the fact that we're having these two triangles that are between parallel lines sharing the same base, it means now that the triangle BDE is equals to triangle CED. So it means now that these two triangles, this triangle that is green and this triangle that is yellow, they are equal because they are between parallel lines and they share the same base, right? So if these two triangles are equal, it makes even the top triangles that we found here using these perpendicular heights equal. So once these two are equal, or these two triangles rather are equal, therefore it makes our equation 1 and our equation 2 equal. So we can just conclude after proving that. We can simply say, okay, fine, so these are equal. So the reason for that, so we need to write the reason. So reason would be that DE is parallel to BC, right? And yeah, you can say same base, share same base. So that is the reason for this portion here. And then you can conclude and say, therefore, AD over DB is equals to AE over AC. So that would be the final solution for this problem here. Now we're going to solve this one here. So we're having a parallelogram and we are told the ratios of BJ and JC. So these are the ratios, and we are told the parallel lines. We are just told all the information about parallel lines. As long as you know the properties of a parallelogram, then you shouldn't have a problem with this problem here. So we are told that BJ, so BJ, this is BJ, it's 2, and here it's 3. So these are just ratios, they're not lengths, right? So 10.2.1 A, we are asked to find ML over LC. So this is ML, right? So meaning the ratio of ML, it's going to go with this 2 here, right? If you take a look, we are having the triangle that looks like this, and this is M, this is L, this is C, this is B, this is J. So these are parallel. So when these are parallel, then the ratios would be equal, right? So ML over LC is equals to BJ over JC, which is equals to, what is BJ? It's 2. What is JC? It's 3. So this would be the solution, right? Yeah, so you can write the reason for this is line parallel to one side of triangle, right? So then now we go to the B part of this problem here. So we are done with this one A. Now we're going to B. AK over KJ. So this is AK. So let me use this color. This is AK over KJ. Right. So for us to find the ratio of this one, it means we need to find this ratio, AM and MC. Right. Why? Because this portion here goes along with this portion here. Right. Cool. So so this is what we're going to do. So to find that, let me erase everything here. Cool. So to find this, we know very well that this portion here and this one here, right? And we know that BJ and JC, BJ is 2 and JC is 3. So meaning that's the same here, it's 2, here it's 3, right? So ML over LC is equal to 2 over 3. It's what we found previously. And we know that MC is actually equals to 5, right? So MC from this point of M to C is 5, right? and that 5 is actually equals to this portion here, from here to here, right? So MC is equals to AM is equals to 5. Why? Because let's just say PAM. You can say PAM because this is a perpendicular bisector. So this portion of the parallelogram is equal to this side of the parallelogram. So you can just say PAM, parallelogram. And so it means here it's also 5, right? So now we are having this, so let me show you. So we're having this portion here now, from here to here and here. So now we can find AK, and KJ, right? Because we're having this triangle that looks like this, right? And then there's parallel lines here. And this is A, this is M, which is 5, and this is L, and then here is 2. So we want to AK and KJ, right? So you can simply say AK over KJ is equals to AM over ML. So this is L equals to, so AM is equals to 5, right? This 5 here. So it's going to be 5 divided by ML, which is 2. So this would be a solution for this problem here. And we can simply write the reason as line parallel to one side of triangle. Cool. So now let's go to 10.2.2. We are given AB being equals to root of 10 units and BC being equals to 2 over 3 of AB. And you're asked to calculate the length of AQ. Okay, so we know that AB is equals to the root of 10 units, right? And we know that BC is equals 2 over 3 of AB, right? So if we were to find this BC, because we know AB, so it's going to be 2 over 3 into root of 10. So now we know BC, which is this one here, which is 2 over 3 root of 10. And remember that this BC is equals to this AD. So BC is equals to AD. The reason you can say PEM, parallelogram, right? That's your reason. So meaning that AD is equals to 2 over 3 root of 10, right? Multiplied by root of 10. So now that we have AD, and remember we want to find AQ, which is part of this AD, right? So what we will do is this. So AQ is part of AD, as you can see. This is what we want here. So AQ is half of AD, as you can see. It's half of AD. Why am I saying that? Remember that this is a parallelogram, and from here to here it's equals to from here to there, right? So these are equal, right? So so half of AD. So what is AD? Half of AD, it's 2 over 3 root of 10, right? So this 2 goes away. Then AQ is equals to root of 10 over 3 units, Alright, so this is the solution for AQ.